Comparison of the basicity of azoles. So azoles are the compounds containing nitrogen in a five-membered ring system. It may contain another nitrogen atom or other heteroatoms like oxygen or sulfur. The question which is frequently asked in the examination: comparison of the basicity of pyrazole, imidazole, oxazole, and thiazole. So these are the structures. Pyrazole contains two nitrogen atoms. Oxazole contains an oxygen atom in position 1 and nitrogen in position 3. Thiazole contains sulfur in position 1 and nitrogen in position 3. Imidazole contains nitrogen in position 1, this is NH, and another nitrogen in position 3. So now let us see pyrrole. This is pyrrole. So it contains NH. It contains NH. So the lone pair of electrons, present in pyrrole. So there is a lone pair of electrons here, which is present in pyrrole. They are present in the p orbital, and it forms a part of the aromatic sextet. Here we have two double bonds. Each double bond contains two electrons, 1, 2, 3, 4, and with the two electrons which are present over the nitrogen, it forms a aromatic sextet, and thereby pyrrole becomes aromatic. So coming to the pyrazole. So pyrazole contains two nitrogen atoms. These two are not same, they are different. This nitrogen contains lone pair of electrons in a p orbital. It contains lone pair of electrons in a p orbital, whereas this nitrogen contains lone pair of electrons in an sp2 hybrid orbital. This nitrogen undergoes sp2 hybridization, and two sp2 hybrid orbitals are involved in bonding with the nitrogen on this side and carbon on this side, and the third hybrid orbital is not involved in bonding, and it contains one lone pair. So this lone pair of electrons present on N2 are in a sp2 hybrid orbital, so whereas the lone pair of electrons present on NH are in a p orbital and involved in aromatic sextet. So coming to oxazole. So in oxazole position 1 contains oxygen, and in position 3 we have nitrogen, which is a nitrogen that is containing lone pair of electrons present in the sp2 hybrid orbital. Similarly, thiazole contains sulfur in position 1 and nitrogen in position 3. This nitrogen is also sp2 hybridized, and the lone pair of electrons on the nitrogen are present in an sp2 hybrid orbital. Similarly, imidazole. If we consider imidazole, it has two types of nitrogens. So this nitrogen contains lone pair of electrons in a p orbital, whereas this nitrogen contains lone pair of electrons in an sp2 hybrid orbital. The lone pair of electrons which are present in the p orbital are involved in forming aromatic sextet to make imidazole aromatic. The lone pair of electrons present on the sp2 hybrid orbital are not involved in aromatic sextet, and this nitrogen is more basic. Nitrogen in position 3 is more basic than the nitrogen in position 1 in imidazole. Next, this is the isoxazole. So it contains oxygen in position 1 and nitrogen in position 2, and this is isothiazole containing sulfur in position 1 and nitrogen in position. So coming to the comparison of the basicities of these compounds, the pyrazole, imidazole, oxazole, and thiazole. So imidazole is the most basic compound and oxazole is the least basic compound. Among these four compounds, imidazole is most basic and oxazole is least basic. So among the four compounds, pyrazole and imidazole, this is pyrazole and this is imidazole, have two nitrogen atoms. In imidazole, the two nitrogen atoms are in conjugation. If we see the imidazole, these two nitrogen are in conjugation with each other, and in pyrazole, the two nitrogen atoms are adjacent to each other. So imidazole is more basic than pyrazole. So this imidazole contains two nitrogen atoms in conjugation, and this is more basic than the pyrazole. So the type of nitrogen atoms are same, but in imidazole the two nitrogen atoms are in conjugation, and it is more basic than the pyrazole. Next, in oxazole, if we consider oxazole and thiazole, these structures are almost similar, with oxygen in position 1 in oxazole and sulfur in position 1 in thiazole. So oxazole and thiazole, they differ in oxygen and sulfur atoms. Nitrogen atom is the same. So oxygen is more electron attractive. So oxygen is more electronegative, and it is more electron attracting than sulfur atom. So the availability of lone pair of electrons on this nitrogen atom, the availability of lone pair of electrons on N3 in thiazole will be more than nitrogen atom of oxazole molecule. This is because of the electron attracting nature of oxygen, makes the lone pair of electrons on the nitrogen atom less available. In thiazole, sulfur is less electronegative compared to oxygen. Therefore, the availability of the electrons on nitrogen atom is more probable. So, we can conclude that thiazole is more basic than oxygen. So, therefore, thiazole will be more basic than oxygen. Hence, the order of basicity will be imidazole more basic than pyrazole, pyrazole more basic than thiazole, and thiazole more basic than oxygen. This is the order of basicity. So imidazole will be the most basic and oxazole is the least basic. This is the comparison of the basicities of imidazole, pyrazole, thiazole, and oxazole. Another frequently asked question is the comparison of basicity between the imidazole and pyridine. Imidazole is a azole. It is a 5-membered ring system containing one pyrrole type of nitrogen and another pyridine type of nitrogen. The lone pair of electrons on pyrrole type of nitrogen is in a p orbital. The lone pair of electrons on pyridine-like nitrogen is in a sp2 hybrid orbital. So pyridine. So it is a 6-membered ring system, and the nitrogen atom contains the lone pair in a sp2 hybrid orbital. So therefore, the nitrogen atom at position 3 in imidazole and the nitrogen atom in pyridine, they are same. Both are sp2 hybridized and containing lone pair of electrons in an sp2 hybrid orbital. So there are two nitrogen atoms in imidazole. One is pyrrole-like and the other is pyridine-like. The pair of electrons on the pyrrole-like nitrogen are located in the p orbital, and p orbital is perpendicular to the plane of the ring and are involved in aromatic sextet. This makes them unavailable for bonding to a proton. So the pair of electrons on the pyrrole-like nitrogen atom are not available for bonding to a proton, because these pair of electrons are involved in aromatic sex state. Hence, pyrrole nitrogen is less basic or essentially non-basic. Pyrrole nitrogen is non-basic. So pKa value of pyrrole is 4. So it is less basic. The lone pair of electrons on the pyridine-like nitrogen are located in the sp2 hybrid orbital in the plane of the ring. The lone pair of electrons on the nitrogen atom in the pyridine type of nitrogen are located in a sp2 hybrid orbital. So over this nitrogen and this nitrogen. The lone pair of electrons are located in an sp2 hybrid orbital and they are in the plane of the ring and not involved in the aromatic section. This pair of electrons on pyridine type nitrogen are not involved in aromatic section. So this makes them available for bonding to a proton and hence pyridine like nitrogen is more basic. So its pKa is 5. So therefore, pyridine like nitrogen is more basic and pyrrole like nitrogen is less basic or essentially non-basic. The availability of lone pair of electrons for bonding to a proton is influenced by the hybridization state of the orbital in which the lone pair is located. Greater the S character, less is the availability for bonding as S orbital character equates with the degree of nuclear attraction that the electrons experience. So the S orbital is spherical in shape. It will have greater attraction on the outermost electrons. Therefore, they are less available for bonding to a proton. So if the electrons are located in a S orbital, they are not available for a bonding with proton. So now the reason why imidazole is more basic than pyridine is because protonated imidazole has two resonance forms. Such that both nitrogen contributes equally in carrying the positive charge. So if we protonate one nitrogen, so the pyridine type of nitrogen can be protonated. Even in the pyridine also, the one nitrogen atom can be protonated. In imidazole, we can protonate the pyridine type of nitrogen. It forms protonated imidazole and it is in resonance. It is in resonance because the two nitrogen atoms are in conjugation. Therefore, resonance structure is possible here in the case of imidazole. So the protonated imidazole is stabilized by resonance and the positive charge is present equally on this nitrogen atom and this nitrogen atom. Therefore, imidazole becomes more basic than pyridine. These two questions are very important for examination. Why imidazole is more basic than pyridine, or imidazole and pyridine, which is more basic and why? Similarly, comparison of the basicity of pyrazole, oxazole, thiazole and imidazole. These two questions are important from the examination point of view.